Welcome. My name is Kalyowa Solomon. I welcome you to my YouTube channel. I teach physics. Okay, now today's topic is current electricity. So the keywords are electricity and current. And now we are saying that electricity is the flow of charged particles. And here the main word is charged. Then electric current is the rate of flow of charge around the circuit. Still the keyword here is charge. Electric current will look at how fast charge moves in a given period of time. Now, it means that charge is important here. Now, we are going to look at how do you get charge, calculations of charge. However, before we look at calculation of charge, we need to know what is charge. Charge is the product of current and time. So we look at charge as the product of current and time. And in this equation, we are saying that charge, we represent it with Q. I is a representation of current, and T is a representation of time. And here, the main thing is time must be in seconds. Okay, because seconds is a sign of time. Now, when we look at the sign of charge, we say it is a column, abbreviated as C. We look at the definition of a column. What is a column? We get the definition of a column from our formula that charge is equal to IT. Now, we shall have one column only if the current is 1 ampere and the time is 1 second. That is when we shall be able to have one column. Okay, now from this we can get our definition of a column, and we are saying that what is a column? A column is the quantity of electricity. Quantity of electricity. Remember, charge is the same as quantity of electricity. So it is in other words, a column is a charge. Is a charge or quantity of electricity which passes through any point in the circuit in 1 second. Talk about 1 second when a current of 1 ampere flows. So when you have 1 second and 1 ampere, then automatically you'll be able to get a column. Thank you. We are back. We say charge is the product of current times time. Now, when we look at this question, current, we said a current of 6 amperes flows through 2 hours in a circuit. Calculate the quantity of electricity that flows in this time. So we have here the current of 6 amperes and times 2 hours. Now, if you are going to have a calculation, we are going to look at 4 steps. Step 1. Step 1, we write the general formula. And we say our charge is equal to I times T. That is our general formula. That is the first step. Step 2, you state what is given in your question. Remember, I underlined 6 amperes and 2 hours. So in step 2, we shall say we are given current 6 amperes and we are given time 2 hours. Remember, earlier alone we had said time must be in seconds. Now, if time is in seconds, then here we have to check if there is any conversion. of units. We say time is in hours, so we have to change it to seconds. So in our step here, we shall say 1 hour is equal to 60 times 60. That is equivalent to 3,600 seconds. Now, so that is the number of seconds in 1 hour. So if there are 2 hours, then we shall say we have this, we cross multiply 2 times this 60 times 60 over 1, and our total time taken will be 7,200 seconds. That is the time the current used to flow in a circuit. Now after this, we go to step 4. Step 4, we have to calculate now the quantity. Remember the question was calculate the quantity of electricity that flows. So it means now we have to get the quantity. Use our general formula. Quantity of electricity is equal to current times time. Substitute. We shall say our current is 6 times the time we have already converted here, which is 7,200. Then when we multiply, our quantity of charge becomes 43,200 coulombs. So this is the quantity of charge. That is how we get the quantity of charge. I hope you have understood. We can look at another question. Subscribe on. We are back. Example 2. Now we are saying define the coulomb as a unit of charge. Of course, we defined a coulomb earlier. You go back and look at how did we define it. Our main emphasis is here. We are saying you have a charge of 1,800 coulombs flowing through a lamp for 2 minutes. Find the current flowing through the lamp. Now, part A, we have said, students, this is students' assignment. You are going to go back in our the first statement. We defined what we call a coulomb. But our emphasis is here, part B, where we are supposed to look at the question wants us to get the current flowing. Now, we are going to break our calculation into steps. We shall start with step 1. We write the general formula of charge, which is charge equals to IT, where charge, Q is charge, I is current, and T is time taken. This is our first step. Step 2, we shall state or write what is given in the question. When we go back to our question, we are saying that we are given charge. Our charge is 1,800 coulombs. Then we get the time, which is 2 minutes. That is the second step. We list what we have from the question. Now, when we list, we look at, can we just substitute in, or there are other modalities? Then we go to step 3. We check if there is any conversion. Okay. Now, when you look at this, earlier we said that when we are dealing with the calculations, then the time must be in seconds. So here we have time in minutes. So it means that we have to convert 2 minutes to seconds. Then we shall say 1 minute is equal to 60 seconds. Then what about 2 minutes will equal to, then we just cross multiply the 2 times 60 over 1, giving us 120 seconds. Now, Remember, you have not yet answered the question. Our question wanted us to get the current. Here we have got the time. This one is helping us to be able to calculate the current when we have the time in the correct units. Step 4, use your general formula. Our general formula is here, and we are saying current equals to I, charge is equal to I times T. So you substitute in our general formula. Q is already given as 1800. Put it there. Equals to current I, the one you want. Remember, you wanted this one. Time was 120. The time you have already calculated. So after getting this one, we shall now solve for I, and our I will be given as, when we look at this equation, when we want to solve, we just divide both sides by 120. Therefore, our current I will be given as 15 amperes. As simple as that. Now, this one is your exercise. You can try out this question. You copy it and try it out to check whether you have understood the steps. Hope you have got me clearly. Once again, I welcome you. You place on that button subscribe, and continue checking for other videos. Thank you.